Hey guys, this is Mr. Yo, and today what we're going to learn about is periodic trends. So before we move on to the periodic trends, we must understand two things: the scientist who created the periodic table and the understanding of how to use the periodic table. So let's begin. First, we have two scientists that we have to focus on in a periodic table, which is Dmitry Mendeleev and Henry Moseley. So Dmitry Mendeleev, or we call it the father of the periodic table, organized the periodic table based on atomic mass. However, the current periodic table is set up as Henry Moseley. He organized the periodic table based on the atomic number, or what we call is the number of protons. So those are the two scientists you must understand before we move on to the periodic table. Next, we have the periodic table. So first, it's organized based off of similarities and differences between the elements. That's why we have the part called period, which is not mentioned here, but it's from left to right. This is period 1, 2, 3, 4, 5, 6, 7. And we have the group or family, which is from top to bottom. So this is called what? We have a specific name of each of these sections. This first part is called the alkali metal. The second one is called the alkaline earth metal. Then we have these sections which we do not know the group's name, but what we call it usually is boron group, carbon group, nitrogen group, and we have a specific name for this. I believe it's called the Callaghan group, which you do not have to understand that group, but that's what it's called. And then we have the halogen group, which is the seventh valence electron, and the noble gas, which is the eighth. So we have one valence electron, two valence electron, 3, 4, 5, 6, 7, and 8. And if we have 8 valence electron, it follows the octet rule, which means having max number of 8 valence electron. And that's what it's talking about in the group and family: similar chemical properties and number of valence electron. And another term that you must understand is periodicity, which also what we call it from periodic table. It means the trend in a physical and chemical property of an element. So this is what we have to know before we move on to the next lesson, which is the periodic trend. So within periodic trend, we have four parts: atomic radius, ionization energy, electronegativity, and shielding effect. First is the atomic radius. If we look at the word atomic radius, it's what we're talking about is atom or atomic, and radius from the center to the outermost valence energy level, which what we call it as OMEL or OMEL, the distance from the nucleus to outermost energy level. So radius, you found this term from geometry, from the center to the outer level. So this is not something that you will learn. This is not something new to you guys. So you should know about this. So within a period, we have left to right, which decreases because of the proton and electron increases, and those are opposite charges. And the outermost energy level is closer to the nucleus. And group. For group, from top to bottom, it increases because every element adds a new energy levels to an atom. And more distance between the nucleus and the outermost energy level would provide you a greater atomic radius. So within these period and groups, we're going to look at the periodic table. So as it goes down the periodic table, it increases. As it goes from right to left, it increases. So the most atomic radius, what would be called as francium. Francium has the most atomic radius because in the f orbital, or what we call it down here, is basically in between these groups, which is lanthanide and actinide. So this is part of the d orbital, or within the transitional metal. So that's what you should know. That's how you present it in the periodic table. Next we have So before we move on, if I give you a question, for example, if I say calcium and gallium, which one has the highest atomic radius? We would say that the answer is calcium, because calcium is all the way at the left side, and we said that as we go from right to left, it increases. So the answer is calcium. All right. Next, we have the ionization energy. It's called the energy needed to remove the electron from atoms, or what we call ions, and stronger attraction between the nucleus and electrons, harder to take away the electrons because we need more energy. Okay, so this basically means that if we look at the word ionization, the word ion basically means positive and negative charges. Okay, so that's how we can memorize or understand what ionization energy is, because it can remove or add electrons due to the word ion. That's what we get the cation, which is the positive charge, and anion, the negative charge. Okay, and you should know that positive charge means losing electron, and negative charge means gaining electron. You should understand that. So if we look at the period from left to right, it increases because closer the atom to obtain 8 valence electron, harder to take away the electron. Okay, so this determines by using the valence electron. Group, on the other hand, from top to bottom, it decreases because elements adds new energy and level to make or to the atom. Okay, so valence electrons are further from the nucleus, and that's why we have atomic radius to be larger, because as we go down, the distance between the valence electron and the nucleus, or the elect the what do we call that? The energy, the outermost energy level distance gets farther away, which means atomic radius increases, which makes it easier to remove. That's why it decreases from top to bottom. Okay, so if we look at the periodic table, this is how it looks like. It increases as it goes from left to right, and increases as it goes from bottom to top. And for in this case, we would ignore, for conceptual reasons, we would ignore the noble gas from this, because noble gases has 8 valence electrons. However, if we have a problem, for example, if we have helium versus zinc, we would say helium has a higher ionization energy because it's all the way at the top. But we would say fluorine would be the most, because noble gases, we don't actually count it out uh, due to conceptual reasons. Next, we have the electronegativity. Electronegativity means the ability of an atom to attract electrons in a chemical bond. So if we look at the periodic table, periods from left to right increases because closer the atom to 8 valence electron attracts more electrons from other atoms. And group from top to bottom decreases because elements adds new energy levels to an atom, and positive charge of a nucleus is further away from the omel, or the outermost energy level, and hard to attract new electrons. So easier way to understand this is this. This is the same thing as this the ionization energy trend. It has the same terminologies. So in order to understand the electronegativity, what you can say is this would be a child who's very stubborn. It has all the valence electrons, or most of the valence electrons, um, and it wants to fill in all 8 valence electrons in order to succeed its throne. So what they would do is probably take away the 1 valence electron in the alkali metal and trying to get into the noble gas area. So we can think of this as a child who's greedy, and this is a child who doesn't have anything except one of its um, goodies, or whatever we want to call it. So you can think of it as different examples in order to understand the electronegativity. So, for example, for this question, if I say what's the difference between magnesium and sulfur, sulfur has the higher electronegativity because it's from all the way at the right side. That's how an example problem would be. Lastly, shielding effect. Shielding effect is it's an effect caused by valence electrons in the outermost electron energy level. are guarded from positive charge of a nucleus by electrons in the inner energy level. So if in a period we have left to right, which stays constant because no energy levels are added within a period. For the group, top to bottom, it increases because increasing number of energy levels and distance between the nucleus and outermost electron energy level. So if we look at the periodic table, it stays constant from left to right, but it increases from top to bottom. The reasoning for this is each of these periods actually represents the amount of orbitals or circles that you see around the nucleus. So first one, we have one circle. Second one, we have two circles, which is going to be larger than the first. Third one has 3, 4, 5, 6, and 7. It keeps on increasing. So please understand that as it goes down, the orbital or the circles would increase one by one. So that's how you memorize the shielding effect or understand it. So these are all the trends that you have. So please review the terms and the definitions, and most importantly, the trends, as in where it increases in the periodic table, or where it decreases, or where it stays constant. So the things that you have to understand is the four trends, which is the atomic radius, electronegativity, the shielding effect, and and ionization energy. So four of those. The two scientists, Mendeleev and Moseley, and lastly, the periodic table. And also, please do remember your electronegativity. I mean, not electronegativity, but electron configuration, the SPDF orbital, which will help you out throughout your exam. So hope it helps, and hope you guys study well. And if you have any questions, feel free to put some comments below. And yep, good luck, and talk to you guys later.